is quite interesting. So,
well, I hope to have more people debate. That's when it gets more fun. And I don't mean debate for the sake of debate, right? I mean, actually attempt to understand and express their perspective.
it is quite interesting. So, okay, so I'll start the recording and I'll start with the introductions, and hopefully other time people will join in and we'll have a little bit more numbers.
Yeah, sure.
Okay. I'm gonna Hi everyone, let's welcome to today's RFCs We Love. Thanks for everyone for joining us on a Saturday morning or a pretty late night based on where you are. A quick introduction, RFCs We Love is a meetup that we organize by IIESOC, which stands for India Internet Engineering Society. We organize various events such as this, which is an RFCs We Love Meetup. Our more famous annual event is called Connections, which we have been organizing since 2017. We have one which is planned for Feb of 2024. So look out for more information coming your way regarding upcoming Connections event. We have also partnered with INTC, where we do various webinars. We had an IPv6 webinar series, which went in multiple phases. We started a security webinar series, which just completed this year, and we might do another in 2024. So if folks have any thoughts about what they want to learn or what kind of webinar series that we can start in future, and if you want to yourself take part in it, please reach out to us. We will be happy to collaborate and work in more topics which our community is interested in. I would put all these details in a chat at the end as well. You can become our members. You can join our mailing list. We are there on WhatsApp as well, which is quite active. We have various discussions related to IETF and standards even that are happening, and keep each other connected. You can also ask for help for various things within the like-minded community here in India, so that you can get some help in moving your stuff within IETF as well. So don't worry, I will share all this in a chat as well, and you can click and join our groups. Okay, so before we go in detail, some admin stuff. We do this in a webinar format. So the best way for the community to raise questions is use the Q&A button in the Zoom. That will clearly give us an indication that that is a Q&A for one of our speakers. You can continue to use the chat for general discussion, saying hello, telling us where you are coming from, what brings you today, and in fact, general discussions on the topic that we are discussing. But if there is a specific questions for our speaker, please use the Q&A so that it's easier for us to track and make sure that we can answer all your questions. And Dinesh had specifically asked he would prefer this to be more interactive, so please don't shy and feel free to ask as many questions as you would like. So this is our plan for the today. We have two very good topic, great speakers as well, with a lot of background in the networking domain. We have Dinesh first giving the role of network observability in network automation. And this talk is going to be very interesting and thought-provoking. So I hope we can have a good discussion around it. And then we can jump to a new work which has been talked about in IETF and other circles, which is use of network digital map, and how we can use some of the things that we use, like traffic maps and Google Maps and observability for traffic, and how can that be applied also on your network management scale, and how would that look, and what would be the building blocks for doing something like that. So that is also a thought-provoking talk from Chin, who's working in this area for a long time, and it would be nice to listen to that. I would end finally by giving some highlights on what happened at IETF 118, and also talk about upcoming IETF 119, which is going to happen in Brisbane, Australia. So that's the plan for today. And let's just kick off with our first talk. So our first talk is on role of network observability in network automation. We would have Dinesh talking about his experience in this area and some very thought-provoking questions in his slides as well. So I would let Dinesh go in details about this topic, and you have already seen the abstract here. So let's just welcome Dinesh. Dinesh is a well-known industry expert. He has written books. He has been with Cisco and in the networking domain for a long time. And he also changed stint, worked at Cumulus Networks as well. And in ITF, he was involved mainly with the Trill work, and he is a co-inventor of VXLAN, has various patents under his name. So it's really glad to have Dinesh in one of our RFCs we love talk for the very first time, and we would love to hear more thoughts from Dinesh going forward. Again, a reminder, please use Q&A and ask questions. And I'm going to stop sharing and pass on to Dinesh.
Can everybody see the slides?
Yes.
All right. Good morning, everyone. Thank you for taking time out of your Saturday to come listen to me talk. Hopefully, this is something that you will find interesting. This talk, I'll warn you up front, has no packet headers, has no protocol discussion. It's a different topic, and that's why I called it Takes from the Other Side. And as you might know, when you see it, the first thing you will want to say is, well, isn't it Tales from the Other Side? But I deliberately tripped on the title, so you will realize that the whole perspective I'm offering here is one that kind of deviates from what you are probably more used to listening. This is an opinionated perspective. It is not an opinionated perspective that's just born out of pulling ideas out of my rare side, so to speak. But this is opinionated based on my experience, and we'll talk about that in a second. If I ask this community, what's a fundamental problem with networking today? What might you say? I mean, pick anything that you might think of. I have a prediction that I'll make, and the topic has a particular title, so don't assume that, hey, that's what I was going to say. So pick, what do you think might be a fundamental problem that you think you're addressing, that needs to be addressed in networking? Doesn't matter. I'll make a prediction, and I will hold on my prediction till the end. I'll give people a couple of minutes if you want to just throw out in the chat. Dhruv or Kannan, one thing I would appreciate is, because I can't see the chat at the same time like I'm talking, if there's anything that shows up, if you could just kind of point to that. Helpful. Thank you.
Sure.
So any takers on what they think might be some interesting problems, or what's a fundamental problem with networking today?
So we have the first one. Often when there are issues in the applications, often network devices are first to be blamed.
Yeah.
That's an interesting this thing. We have operational simplicity as the second one.
Yeah. Hey, you guys have read the slides. That's unfair.
No, this is not from us. I'm reading from the chat what our attendees are saying.
I understand. No, I wasn't talking about you, Dhruv. I was talking about the audience. I know it wasn't you reading because you spoke. Yeah.
Yeah, actually, because I have read the slides. So
yes, I know. That's why I wasn't going to point to you, but that's good. I'm glad people are mentioning these kinds of statements, because I do believe that a fundamental problem, I think this is actually the fundamental problem, because everything else relies on this, but we'll talk about that in a second. And again, that's an opinionated perspective. I think a fundamental problem is, even to this day, getting a systemic view of the network and the ability to act on it is missing. This inability to get a systemic view of the network and act on it causes all kinds of downstream problems, which then take on their own life in an attempt to solve, but they don't really address the fundamental point. What does it mean to have a systemic view of the network? To me, a systemic view of the network is to understand a landscape, have a view of the network from a perspective that tells you where the lay of the land is. As an example, you should be able to use this perspective. Think of it almost like a Google Maps. And it's funny that you have someone coming to talk about digital map after this. But the fundamental point is you should be able to picture your network as a Google Maps thing or a Google Earth thing where you can zoom in and zoom out, but also be able to zoom in and out as time. So do both time travel and space travel in terms of perspective to be able to understand what your network looks like. Today, this is just completely missing. If you talk to any network operator, what they will tell you is, oh, when you tell them what is wrong, they will fire typically a trace route, or they will use their memory and their experience with the devices to log into a box, and then they'll go from box to box to box to box. And every single time, they will build a map of what might be the network and the problem in the network using this step-by-step approach. And we are in 2023. So the focus of this talk is how can you developers on network devices help with network observability? Because if I talk about network observability and its use, it's a very network operator focused side. It's a side that I did not see when I was at Cisco. Many of you probably haven't seen, you have not sat with a network operator and watched them do any of their daily tasks. So this is the part of this talk, or the basic theme of this talk is to say, if you were on the other side and you saw and you could communicate what you wanted, what might you say? So the first question that comes about is, wait a minute, dude, weren't you also working at Cisco? Dhruv said you worked at Cumulus. Why is your perspective important? How is it that you arrive at any piece of information that tells us that we should pay attention to this? Most of my perspective comes from my time at Cisco, my times more specifically at Cumulus, and the time I have taken to develop this open source software on the basis of which I've started a company now called SuzyQ. And for those of you who wonder what SuzyQ is, it's based off the rock song from CCR. And if that shows you my age, hey, I think it's still a pretty good song. So what is it that I want to tell you comes from my perspective at Cisco and at Cumulus? When I was at Cisco, outside of the first couple of years, I was chiefly an architect. I worked on all the pretty big major platforms that you might know historically, the Catalyst 6500, the MDS 9000, the Nexus 7000, the Nexus 5000, a couple of weeks at Nexus 9000, and then I quit. But in general, that's been my perspective. And usually when I joined, I was an engineer, and then when I left, I was a fellow. They would trot me out to talk to customers, or when I was working, I would be working on the architecture of the chips. I was the liaison man who dealt with, okay, I heard all these problems from the customers. What can we do in the chips to make sure that we can provide innovative solutions? And then how do we marry what is done in the chips with the software that is being developed? I didn't write any piece of code. I didn't write code for almost 12 years, but that was what I did at Cisco. What it did is it kept me completely isolated from anything but a network operator talking. But it wasn't the network operator who would talk to me, right? What I would be talking to, who I would be talking to is the director of IT or the senior VP of infrastructure in a company. The way they explained the problems and what they were talking about was very different than if I spoke to the people who were in the trenches. So I never saw that view while I was at Cisco. So my perspective was I never really understood what the network operator's pain point was. And then what happened was OpenFlow. So OpenFlow came about, and there was panic in the company about, oh my God, OpenFlow is critical, is a new technology. There is a threat that's possible, and this could affect Cisco in a bad way. So we should do something about it. Oh, by the way, we looked at OpenFlow V1 that doesn't even have ECMP. You know what? We can do much better than that. Let's take care of this. Microsoft at that time was very interested in OpenFlow, and it said, hey, you guys, do you have an answer? So they had me and my boss at that time, Tom Edsel, trot us out to Seattle. So we sat down with all these people, and we said, you know what? OpenFlow sucks. We will do a Cisco Flow. It's fantastic. It's going to do everything under the sun, and it'll be beautiful for you guys. They said, fantastic. When you have it, come on over. Let's deploy it. Let's figure out how it works, and then we should be good to go. So everybody was shaking hands. Everybody was very happy. But I hated OpenFlow right off the bat. I thought it was a very, very weak and inappropriate solution, but I didn't know what the problem it was that it was trying to solve. I didn't fully grok that. So I was puzzled by why is everybody so interested in OpenFlow? So in that meeting, I said, before we all vanish off and develop this thing, if I were to ask you a simple question, let's assume that Cisco Flow is with you. It's in your labs, in your network today. What would you do with it? And the guy said, oh, very simple, Dinesh. I'll program VLANs. I said, huh? The guy said, yeah. Do you know how I have to go configure a device? And I said, no. He said, well, imagine you give me a new upgrade. How do you think I have to do it? I have to manually upgrade the device, wait for it to reboot, and then go on to the next one. And when I configure a VLAN, that's my only choice. I have to go log into the box and configure the VLAN. That made me realize right away that the problem that the users were having was different from what OpenFlow was supposed to solve. There were people from the academia coming, there were people from other places coming, and each of them wanted a slice of OpenFlow in a different way, but it wasn't tackling the problem that the network operator was having. I quit Cisco a year or so later because I was focused on trying to solve this problem, and the way they were looking at it, I wasn't interested, but it looked like InCMA was going to solve it. So I went to InCMA for a couple of weeks because they wanted me there. The forwarding that InCMA does, the basic idea was mine. And so they basically wanted me there. But after 2 weeks, I felt that they weren't doing what I was focused on. And so I quit. I thought I was done with basically networking because I thought I had done everything and nobody seemed to be interested in solving this problem. So I walked away. And then JR called me at Cumulus and said, hey, Dinesh, I want you to come join Cumulus. And that was a completely different journey because as a startup, you get to see the world in a very different way. You are not just somebody who gets trotted out to talk to the big wigs, but you also are the person who gets trotted out to the person who's deploying this equipment. So you got to sit with them, watch what they're doing, et cetera, et cetera. That gave me a different perspective of how people looked at networks compared to how we did it. And correct me if I'm wrong, I suspect most of you are in a similar position. Maybe if you are a carrier on the carrier side, which is on the ISP side, maybe you work with the customer a little more closely, but I doubt if you are still going to be sitting as closely as in the trenches to see how they actually approach certain things. If people disagree with my perspective, please always stop me, correct me if you disagree with me. I'm happy to take a different perspective. I've tried to make this about learning, not about what I know. So hopefully we can enjoy and understand each other's perspective here. And so that gave me the impetus to say, I want to think about how to solve the network in a very different way. And that's what led me down the path eventually of SUSE-Q. So I wrote a couple of books after I quit Cumulus, and then I started this more as a labor of love. So today, just 30% of the tasks are automated. Everybody understands that network automation is critical. Why is it important? There are lots of reasons why network automation is important. I won't waste your time repeating all of that. But a key problem is the fact that you want to stop having random errors. You want predictable errors. And you want to make sure that the tasks are not onerous, because just sitting and typing the same command over and over again is just ridiculously useless and a waste of everyone's time. And the simple important fact is that that causes random errors, and that's really bad. But this was we have to automate the network was a big thing when I joined Cumulus. This was 2012. It's 2023, and still 30% of the tasks are automated today, nothing more. Network automation, besides the fact that it's only 30%, is largely still confined to configuration. People write up a Jinja template, write a bunch of variables, either using Python, Ansible, Salt, pick your favorite thing. They use that to then push this configuration, render this template into an actual configuration for a specific device, push the device. That's the end of automation. People largely don't know if this configuration that got pushed is creating a problem or not. The only way they know that is by, again, logging into box after box and verifying that everything is fine. As you all know, to err is human, but I put in the family-friendly word here. But to really F things up, you need a computer. So, okay, fine. Why is it that much harder? If people can push configuration, isn't it not a big deal to go ahead and do some of the other things post configuration? No, the problem of testing is actually far more complex because the network is a distributed system. Testing a distributed system is really hard. And networks were probably the first distributed system in a way, but nobody really debugged networks in an automated fashion at all. And most networks, independent of what people say, are snowflakes. Even two hyperscalers don't build the same network the same way. Amazon uses OSPF plus BGP in its own way. Microsoft uses all BGP. Arista uses, not Arista, what am I saying? Google uses their own centralized control protocol with a mishmash of distributed, and they have their own way of doing things. Every hyperscaler is different. They have the same class topology, but even the class topology is sometimes different. If you look at the class topology that Facebook puts out, it's a little different from the one that Amazon puts out. So most networks are snowflakes. And if you go into the enterprise, they are all completely different. There could be two banks, but they'll be largely different in their configuration. The topology may look the same, but otherwise their configuration looks different. Which means for you to make a configuration change, push and test, it's much harder. And of course, you need programming skills. Why? You need to parse the output. And there are multiple endpoints. You have to make sure that all the devices in your network are correctly doing things. You got to be able to aggregate information. The skill required is actually a fairly sophisticated skill. It's not a simple configuration template, update and push. And that is why observability tools can help overcome the issues of testing, of looking at your network systemically and being able to understand if the changes you are making, what is the effect of those changes on this system. I have kept saying observability a couple of times without really defining anything. Dhruv, please feel free to stop me anytime you feel like there's a question that's worth answering. Or you just want answered, people have, please go ahead and stop. I'll let you be the judge.
Yeah, so if anybody wants to talk, I can always allow you to talk. Just raise your hands and I will do that. Right now, there are no questions. So Dinesh,
Okay.
Go ahead.
Okay. So I have not defined observability so far. And it was interesting. Recently, there was a network automation conference and someone asked in the audience, apparently I wasn't there, what's the definition of observability? And people couldn't really answer it in an effective way. I defined network observability in my book that I wrote as the ability to answer any question about your network. How easily you can answer that question is a measure of how observable it is, but it's basically the ability to answer any question about your network. That tells you whether you can observe and what you've observed, and therefore what inferences can you draw or what specific statements can you make about your network. What are some of the sample questions? I want to deploy a new VLAN, and I've decided I want to pick VLAN 410. Is it already used anywhere? Some people say like, oh, you know, the network statement of truth has to be the place where this kind of repository is present. Technically, theoretically, ideally, yes. But practically, people start with brownfield networks. They can't be really accurate. They have to look in the network to see, is it there? And is VLAN 410 already used anywhere? I have 50 devices. Just figuring that out can be pretty complicated. And remember, it's not whether the VLAN 410 is properly configured, traffic is flowing. All I need is one corner device having VLAN 410 enabled, and nobody is looking at it. And now all of a sudden, if that corner device is not supposed to be part of VLAN 410, when you turn on VLAN 410, you are in trouble. So you can't just look at one box or two boxes like the distribution switches or the aggregation switches and decide, oh, there is no VLAN 410 there, my problem is solved. That's what makes networking really complicated, because of the inability to answer these questions and the side effects of these questions, of these, what's the word for it? Incorrect information in your head. I did a network OS upgrade. I did nothing else. There was a bug fix. I got a network OS upgrade. So I got a new OS update. I did it. Now is the state as expected after the upgrade? We really don't know today effectively. People who are been in the networking, that particular enterprise networks or ISP networks thing have got a set of things that they can check, but it's again, very, very driven by your experience with the network. There's no systemic way to do it. and I want to decommission a model. Cisco sent out, or Juniper sent out a report saying like this model has been discontinued. So we got to take it out of our network. Where is this? Where are the devices that represent this model? Even finding simple things like this is phenomenally hard. And when I have taken the time to develop the Suzy Q and now it's being deployed in people, I have people coming out and saying like, I never thought I could answer these questions. And so one statement I got from people, from one of the customers is, Dinesh, we didn't realize we had stopped asking hard questions of the network because we never got good answers. And now we can again. I don't want to talk about Suzy Q and what it does, except to say that these questions are not just my questions raised in an ideal fashion, but these are questions that a network operator deals with every day. And a network operator is your user, right? So these questions and how they answer them matter to you, because at the end of the day, you're writing software that matters to and affects these people. And in my opinion, network observability is essential to network automation because you can do the critical part of pre and post config validation. You can actually look at what the state of the network was before you made the change. Was a default route pointing out this particular thing? Okay, after I did the upgrade, after I made the change, is it still pointing out the same interface? What about the rest of the routes? What about the MAC table? What about BGP? What about OSPF? All of the stuff to do the pre and post config validation, you need network observability. Troubleshooting is another example. And then there are just general questions with respect to other tasks. I have a customer who wants to, who basically said, I want to replace one vendor with another. And they were planning to go with a white box device. They didn't know if they could move because they thought that they had about 30,000 MAC addresses in their network. They were scaling very high, so they thought 120,000, and they were not sure if a white box could handle 120,000 MAC address EVPN network. But they thought they had 30,000. When they actually checked with Suzy Q, they found that they had 5,000. And so even if they went tenfold, they would be in 50,000. They were not troubleshooting anything. This was more about network planning. But these are all different questions that can be addressed by network observability. But observability requires you to pull together more data than just metrics. Today, you talk to most network operators, all they do is they pull SNMP interface counters, environmentals, CPU, and that's pretty much it. Most people don't pull anything else. They have traps. So if an interface goes down, they get notified that there is an interface went down, but they don't get any context around that.
Hey, Dhruv and Dinesh, there's one question that has cropped up from Kavya. The second of the sample questions that you put up, right, a couple of slides back, how to identify the state of the network to decide whether it is as expected or not. Is state only, the question is the state only limited to configuration checks? If not, what all parameters do we consider as state of the network?
So to me, state of the network is not configuration, it is the actual operational state. Configuration is what you expect. So for example, the configuration is peer BGP with this IP address. The state is it really configured? Is it really in established state? Is it actually exchanging prefixes? The configuration says, I want VLAN 410, but maybe you had VTP enabled and VLAN 410 got disabled because it couldn't really go anywhere. So the state is different from the configuration. Hopefully that answers the question. If not, I'm happy to explain further.
I think it does. I suggest going ahead.
Okay. So it's 2023 and it's yet pulling data from devices is like pulling teeth. So even though I want to pull a lot of data, I can't. Because I have taken personally, because of Suzy Q, I have actually sat and looked at all these devices and pulling data from them from different vendors, and it's like pulling teeth. So from one perspective, you say, well, this is an interesting problem. You say that we have got to address this. Why don't we sit together and work on some RFCs to address this problem? Because, you know, we need to develop a standard to address this. Why don't we develop a new standard to address this problem? So how many RFCs do you think we need to address this problem? We have to look at transport. We have to look at data models. We have to look at a whole bunch of things. So how many RFCs do you think we need? Any takers? My answer is 0. And the rest of the talk is structured around trying to explain why it is 0. So the first thing I want to address is the myth of the uniform data model. And again, this is back to my love for rock music. It's an old classic. What's so funny about peace, love, and understanding? So what's so wrong? What's wrong with the myth of uniform data model? For those of you who don't know what the myth of the uniform data model is, it is all vendors will come together in harmony and peace, develop a standard, provide a vendor-neutral way to export data from all devices. This is the myth. And we have pursued this myth incessantly pretty much from the time SNMP was born. But this myth is like the Peanuts comic with Charlie Brown and Lucy. For those of you who don't know, basically the joke, a running joke in Peanuts was, Lucy always presents a ball to Charlie and says, Charlie, come kick the ball. And every time he tries, at the last minute, she does something and pulls the ball away and the man falls down. Our attempt to address this myth of the uniform data model is exactly like that. Every time someone has put their head to it, it's basically gone the way of the dodo. And I think insanity has a networker's definition, doing the same thing over and over again, but with a different protocol and expecting a different result. Now, some of you might say like, wait a minute, Dinesh, that's not entirely accurate. We do have OSPF, which is a better, superior version than RIP. Don't tell me that we didn't.
Did we lose Dinesh?
Yes, I think so.
Sorry, folks.
Can you hear me?
Yeah, we can
Yeah,
hear
he's
you now.
back.
Minute we lost you.
Oh, I'm sorry. Where did you lose me? Should I go back and finish this slide again?
Yes.
Okay. So insanity is a networker's definition. And the insanity of the networker's definition is doing the same thing over and over again, but with a different protocol and expecting a different result. Now, some of you might say, like, didn't we do that with a different routing protocol and didn't we achieve a better result? Yes, that's true. But that does not translate to other situations. That's a case where it was successful, but a lot of times it is not. And one example is, if you look at our world, we had SNMP first. After SNMP, we did netconf yang. What is netconf yang? It's just SNMP with XML. Honestly, anybody who wants to take a dips on this is different than SNMP with XML, tell me. I'm happy to be challenged on that. OpenConfig, which followed netconf, is basically my XML is better than yours. IETF is taking too long to develop the standards for the Yang data models for a particular thing. A big honking vendor, operator, I'm going to tell you what I want, vendor. If you don't support it, I can't install you in my network. And since we are such a large network and we offer you so much money, a whole bunch of people jumped on this bandwagon and did OpenConfig. And then came GNMI, which is basically my encoding RPC is better than yours. When you did OpenConfig with XML, XML is such old technology and it takes so much voluminous data that it is just ridiculous. So the output was so terrible that, for example, with one of the devices, when I attempted to pull the data using XML, about 100K of data using CLI output was roughly 2 megabytes or maybe 3 or maybe 5, worst case. The XML output, the OpenConfig using the OpenConfig XML output was 200 megabytes. So people said, this is ridiculous. We need to improve the encoding. So they did GNMI, where the encoding is binary and it is running over protocol protobufs. And it's basically, they also said, well, since we are doing all that and we are doing gRPC, let's just also do a push rather than a pull. The push versus pull is, to me, a different problem, and it's not really that interesting, but that's a separate topic. But this is what I mean by saying all we have done is just reinvented SNMP over and over again. And I'm not even talking about things like COPS with PIB, which was basically SNMP because I did PIB. I know how that whole thing came about. I was there at the birth of it. So, but we have just repeated this model over and over again. Do people feel differently? Any perspectives that feel different?
Well, I have one, but I will wait for the end of the talk.
Okay.
If others want to jump in, please feel free to do that. Let's have a discussion.
Yeah, I'm like I said, look, I'm not here to say I know everything. I'm here to learn. I'm happy to be wrong. So I think I heard this quote attributed to Jeff Bezos, and I thought it actually applies to so many things we do. And he got asked this question. He said that, I frequently get the question, what's going to change in the next 10 years? But far more interesting is what's not going to change in the next 10 years, because on that, you can do a real business because it's not going to change. And in his case, he said, customers aren't going to say, I'm willing to pay a higher price. Customers are not going to say, I will take up inconvenience, etc., etc., etc. Now, I don't believe in monoculture, so I would have done that, but I do that, but that's a separate thing. In general, you can build a business strategy around things that are stable in time. Similarly, we, from a network observability perspective, and you as vendor software engineers can take a perspective, which is what is stable in time? What's not changing no matter what you do? What's not changing is vendor differentiation. When you want to develop a feature, vendors will differentiate. It doesn't matter what it is. You do VXLAN, Cisco will add an additional header to use the extra bits. Someone else will add another different bit and say, I don't like layer 2 versus layer 3, I'll add a protocol. Somebody else will do something else. So people are always trying to vendor differentiate. And a consequence of vendor differentiation is when you're trying to build this uniform data model, it doesn't work because one vendor, because of their differentiation, their attempt to innovate, will be ahead of the others for a particular thing. And then what do? They can't sit around waiting for singing Kumbaya to have the data model come out. They're going to come out with a model that works for their situation. And then it goes to the IETF where everybody sits around, tries to make this a little more uniform, and then you have that come out. Meanwhile, the vendor has added 2 other features after that. But now you as a network operator are like, what do I do? Which data do I take a look at? And if you are an observability software or a monitoring software dude, you have other problems. Which data model do I look at? Do I look at the standard data model or the proprietary one that the vendor put out? And by the way, you have to deal with the proprietary one anyway. I frequently get asked this question as part of SuzyQ when I go to talk to people. Oh, Dinesh, how are you pulling data? I say, I pull the data this way. They say, oh, but why aren't you using netconf? Why aren't you using this? Why aren't you using that? And I say, because of various reasons, and I quote my reasons. And then they say, great. We have a follow-on question for you. Yes. When you switch to netconf, how will you pull out the proprietary information? So you just told me you want me to switch to a model which has problems, and then you want me to address those problems. But you don't want to look at the model where those problems don't exist. I basically do away with them. So vendor differentiation is always going to exist. And because of that, you're not going to have the uniform data model. Developers need to debug. Because of that, there'll always be a CLI. There'll always be a show command. Even for those who present a GUI, you will have a REST API or some kind of API. For example, if you're a Palo Alto Networks and you say, I don't have an SSH. No, you do have an SSH. But if your user perspective is a GUI, then you have an API. You are exposing that API. That API is probably not open to any standard. It's your own thing. The next is devices have a long tail life. So when I did SuzyQ, I said like, oh, you know what? I'm going to implement just JSON output parsing. I will use NXOS. For NXOS, I'll just take JSON output parsing. Well, JSON output parsing in NXOS had various versions. There was a version that was native. Before that, there was just non-native. If you took the non-native one, they had weird stuff going on with their JSON output. When you did the native version, it wasn't supported on all devices. So one of the users said, Dinesh, if all you do is parse NXOS JSON, I have 300 devices for you. If you're willing to parse the text output of the show commands, I have 3,000 devices for you. And that's not going to stop anytime soon. I ran into networks where people were running it for 8 years. The box was up with an uptime of 8 years. First of all, kudos that, as software developers, you guys developed something that was up for 8 years, not shut down. But that also tells you that devices have a long tail life, and operators won't upgrade unless they have to, which means devices will continue to run with the older models. So all these new protocols you're inventing is not going to come into effect for a very long time. And all the data you ever wanted but were afraid to ask is just a show command or a REST API call away. Everything. In fact, I pull more information and more accurate information using show commands or REST API calls than I can with any available protocol like netconf. Because netconf is a model, fits in with a particular set of things. And when you get out of the thing, like we talked about, it's not there. Other times a feature gets developed, didn't really add a netconf model. Why? A large hyperscaler didn't care about that particular feature, so no one took the time to implement it. I mean, if for those of you who are around long enough to know SNMP, know that's how it was. We did a lot of the work, but we never added the SNMP MIB till a little later. It always came later. Okay, I lied. There's also flow export and syslog. Those two are a little different, and we do have things like IPFix or sflow, and we export them that way. And there is syslog you use for logging. So those two are a little different. But I think in general, you agree, you can see that using show commands or REST API calls, you can pretty much get whatever it is that you want. You don't need another protocol for this. So you say, okay, this is great. I mean, you just basically told me I have no innovation to do here, but is there anything you want us to do? Yes, I believe there are a bunch of things I would like you to do. First of all, I believe vendor-specific and consistent data models make more sense. I'm not saying data models are irrelevant. I'm just saying the myth of the uniform data model that works across all vendors is an impossibility. It's a pipe dream. But each vendor developing their own data models and keeping them consistent and publishing them makes absolute sense. What does that mean to say I have a data model? Basically, it means I've got a data structure, I've got a set of fields, and those fields have specific types. That's roughly, and there is a structure to them. That's roughly what a data model is. Can you guys continue to hear me? No problems?
Yes, Dinesh.
Yes, Dinesh. There's one question here from Bharat Joshi. How important are syslogs for network observability?
It depends very much on what is the problem you're trying to do. For example, today, there is really no way for me to get information about, what's the word for it? An unauthorized login attempt other than syslog. Some other kinds of information are only available in syslog. So I would say syslog is important. Not as important as something else, at least in the networking devices, but it is important. For example, if you look at firewalls, it is critical because the firewall logs are everything that tell you about what is going on that device. So it depends on the particular thing. On a switch or on a bridge or a router, it's probably not that critical except for certain things, but on things like firewalls, they're really fundamental.
Dinesh, one clarifying question also. When you say REST API to the device, what do you exactly mean? Like, is this a REST API or is it like a REST API vendor that you want to directly use?
Yeah, so the vendor, so for example, if you look at Arista, you look at NXOS, they all have a way to use HTTPS to pull the information out. And what do you send in the REST API call? It's the show command. You're using HTTPS as the transport instead of SSH as the transport. That's largely what I mean by REST API.
So even RESTconf will fit into that definition, right?
It will, as long as now I fall into, the moment I go into RESTconf, if they say, look, RESTconf is my own data model, nothing to do with any vendor or anybody else, then it may be okay. But again, my question becomes there, is the RESTconf model as complete as the show command output? If it is, I'll take it. I don't care. I have to anyway parse the data. But if it is not, no, I don't want RESTconf. I'll stay with the show command output.
Dinesh, I think like one at a fundamental level where I see a little bit of disagreement is you believe that like and correct me if my understanding is incorrect here, and where I thought that there is some value at least where the ITF standard models provide. And in fact, it's incorrect to say that IETF ever imagined that they were never going to be vendor augmentation. It's a part of the protocol. It always imagined that they are going to be vendor augmentation. But the idea at least was that if we can all agree and come up with the common minimum model, that further can be used by augmentation rather than everybody starting from scratch. And if you look at our show commands are like that. Everybody starting from their scratch, totally doing it in a different way. Whereas having a common Yang model at ITF, which does not solve everything, but every vendor augmenting that base model helped the situation. And this is the assumption that I always had, and we have some other people on the call who have worked in this area as well. Are you saying that that's an incorrect thing for me to say?
Yes, because fundamentally, your point is absolutely correct. The protocol has the ability to augment. Agreeing that I have a model where the basic idea of a peer is a particular thing is great, a BGP peer. But you know what? The moment you did that, I have a small portion that is belonging to that is vendor agnostic and a huge portion that is not. And if you thought that this is actually the other way around, there's actually a large commonality and only a very small that's vendor, that's absolutely not true. Because remember again, the problems you have from your perspective as a developer, you are like, dude, I just implemented it. It's in NXOS 9.3. But you know what? I have 3,000 devices running NXOS 7.1. Can't do anything about that. And they are not upgrading it to give me a common RESTconf. And by the time everyone standardizes on 9.3, the standards have moved on. It's something else now. And 9.3 is implementing a specific version again. So this idea of trying to match a standard which everybody has to agree on almost never comes around. It didn't happen with SNMP. For all the work done with SNMP, the only things that I've seen people gather with SNMP are interface counters, some environmentals. There are a few people here and there who seem to pull the information about BGP or OSPF or something else, but by and large, nobody does anything else. Why? Because the common is just interface counters and the environmentals. That's it. That's the only thing that's common across all. So everybody just genuflux to the lowest common denominator. The rest of it is like, God help me. Because I also don't know which version is implementing what.
I think we have Pawan who wants to speak. So I also have thoughts on that, but I'll rather let...
Yeah, let's please have a discussion. I've been eager to have this discussion.
Speak first. Pawan, go ahead. I have given you permission.
Thanks, Dhruv. Thanks, Dinesh, for slides. So I do largely agree with you that finding, say, a vendor-neutral data model for every device-specific config use case is probably a pipe dream, at least at this point in time. But is there? I want to get your perspective on, like, is there a merit in having a vendor-neutral data model for expressing service intent? So I mean, that is not, I mean, there's no vendor-specific differentiation that comes into play there. But from an operator's point of view, if they want to express the service intent in some neutral manner and make sure that that service is being catered to, don't you want a uniform way of expressing that and getting data that ensures that the service is being catered to or not?
So I would start with asking a question. What's your example of a service? Can you give me an example of a service and the intent?
L3 VPN service. I mean, I want to provision a L3 VPN service in the network. I would I would express the service specific attributes in some uniform manner, and then there's probably some entity that takes that intent, converts that into vendor specific native schemas, pushes down the config. I mean, I don't care how it's done, but in terms of expressing as a network wide intent, I would still like to have something that's uniform. That's where I was going with it.
So I would say first stop using the word intent, because intent has got like tons of things. And today I was listening to a bunch of people saying like intent is basically dead. Nobody cares about intent because it never made any sense. So I never thought intent made any sense, because to me intent was too broad a term. I think declarative versus imperative makes more sense. where you declare, I want a VPN service with these characteristics. That makes sense. To me, that's not intent. That's just being declarative, as opposed to, in order to configure this L3 VPN, I want you to do this, and then I want you to configure BGP like this. So that's procedural or imperative. So there's a difference. So I think declarative makes more sense. So let's agree on that. So from the perspective of L3 VPN, again, I believe there are certain things that make sense, but a whole bunch of them don't. For example, if you are trying to build an L3 VPN service, potentially using characteristics that's supported by a vendor where the BGP offers certain characteristics versus it's done via LDP, and that offers a different set of characteristics, you may not be able to express it in a vendor neutral fashion.
I mean, I don't want to specify exactly what protocol gets used to cater to the service, right? But just saying that I want an L3 VPN service between these set of endpoints with these set of SLOs and SLEs, that's good enough for me. And that I believe should be uniform.
So are you a vendor or are you a network operator?
I'm a vendor, and there are IETF data models that do fall under the service model category, and I do see that there is merit there.
And Pawan, in this case, you can actually wear your working group chair hat as well.
Sure, yeah, and like Dhruv said, I do chair a working group in IETF that does generate a fair number of data models, including device-specific models, and they have been working, like you said. I mean, folks have been working on these for a while now, and some have been successful in the controller space, some not so much on the device space.
Exactly. And that's my point. I think they have not been successful because at the end of the day, there are three things like I mentioned. Networks are snowflakes. Every operator wants to do things a slightly different way. I mean, just take a simple example. I want to build a BGP fabric, okay? Class topology. That was where I sat with the devices, did my stuff. So I'll be a little more precise there. I sat down and I want to build a fabric. You speak to Cisco, they have one answer on how to build a fabric. You speak to Arista, they have a different answer on how to build a fabric. You speak to Juniper, they have a different model. At Cumulus, we had a different model. Everybody has a different model, and therefore your ability to express certain things as to simply say do it is harder. We can do something that everybody agrees. So companies like Apstra, for example, that was their whole procedure. They thought, hey, if we can just take this snowflake away and just make it and say, these are your only choices, you'll be successful. Guess how many people use them today? Because the problem, I think, Vishnu, is it's not specific to how we as developers think. It's finally how it gets deployed. All this work on netconf, by the way, has been going on forever, right? SNMP has been going on forever. I work closely with Keith McClory, who was the father of SNMP. How many MIPS really got actually in use today? Nothing but interfaces and environmentals. And I say nothing, obviously, with a little bit of tongue in cheek. Like I mentioned earlier, there are a few places where people do look at other things, but in large part, no one looks at it for that reason, because it's vendor specific. So yes, we would all like to do it that way. And there's a lot of desire, but it seems like at the end, what comes out is never that clear. And take this simple example. So you're working on this service intent, you're taking the time in the service, in the standards bodies, and you're working to make all this happen. Meanwhile, operators need to go do it. They need to go do it. They can't wait for you to develop this service intent. So they go talk to Cisco, they talk to Juniper, whoever it is, and they say, I want it done. They are offered a particular way to do it. It's encoded in their workflow. Getting them to change that workflow is going to take time. And meanwhile, the model which use the service without requiring any specific standards model is pretty robust because it's been developed, bug fixes all have happened, everything has happened. From an operator perspective, they've got this new piece of code that's untested. They have to start using that. Why would they do that? I mean, this is the fundamental problem that we, I think, as vendors face. How much IPv6 deployment is really there outside of Europe and Asia, maybe Japan, Asia and Japan and some parts of Europe because of the lack of IPv6 address. Everybody is making do with NAT. The trouble is when you have solutions that take so long to come about, people make do and they move on, it seems.
Yeah, Dinesh, I'm sorry, just looking at the time as well, and we have
Yeah.
one more person who wants to speak. So, Shraddha, go ahead and let's answer this pretty quickly so that we can move to the second topic as well. Shraddha, go ahead.
Sorry about that.
Quick comment. Can you hear me?
Yeah.
Yeah.
Quick comment, Dinesh. So I couldn't agree more on your slide where you said, the what will not change is the vendor differentiation.
Yep.
So I hope my customers who are forcing us to, sort of comply to certain model could understand this. But one more comment I had was, you said that you talked about show commands, implement more show commands, which will sort of cover all the information that would be required. But my understanding is that some of these open config and these models have this on change sort of streaming, which is, so it's a push model, and it's, when something changes, only then you push. For example, an adjacency goes down or comes up, you push the data. Otherwise, you're not continuously
I'm familiar
pushing
with GNMI.
If, yeah. If you depend on show commands, then you have to periodically pull that data, which seems like an overhead and not so effective or not so
You're absolutely right,
optimal.
Shraddha.
So
Sorry, continue. I have a very New York, what they say, New York style of speaking. I agree with you as you're speaking too. I didn't mean to interrupt you. I apologize. Please carry on.
Yeah, so I wanted to hear your thoughts on that. I agree that there may be a lot of, but my opinion was that, there are some certain things that are good about open config and all these streaming stuff, the push model. So just wanted to hear your thoughts on that.
So I think it's good to always advertise change. Let me give you a simple example. Every single MAC table entry, every single routing table entry has a change, a timestamp associated with the change, right? It says this routing table entry was updated at time X. It's there. Do I have a command that will use the time? Can I say, show me all routing changes from time X? No, I believe only Arista implements it, nobody else. Why? It's there. Every command gives me that output. All I need is that. I don't need a pull or a push. Pull or a push is I think, again, it's like half a dozen of one and six of the other. I think pull or push makes a lot of sense with event-driven notifications, right? I want to react when a link goes down. I want to specifically know right away. You had SNMP traps before there were event pushes. Open config is, GNMI is, I mean, it's useful in a way, but it's not really a game changer in any meaningful way to me. And plus, remember, by the time today with GNMI, not many devices exist which support GNMI. When they end up, everybody ends up supporting GNMI, then we will talk about it. But till then, I still got my 10,000 devices that I have to deal with. What do I do about those?
Dinesh,
That's part of the problem with networking.
The part of the problem which would be same for even show commands. Like you have what you have, people are not going to upgrade.
Yes, that's true. That's true. But you can make some changes with show commands. And that's what I want to talk about. You can make certain things that I will talk about that does not require you. It actually requires you to not do work. First of all, if you have show commands and you've got a type, like for example, in the second bullet, if VLAN was a string 1 and you say, oh, shoot, let me change it to a number because VLAN is a number, don't do it. You just added a change, which makes sense from a developer perspective, is really painful for the guy who's parsing all of this information, because now they have to look at the version, understand, is it a string I'm getting, is it a text I'm getting, and handle that. If you got MTU and VLAN ID, don't make the value, if it is not important, NA. Give it a negative number. Treat your existing command output as your contract with the user and make your testing, check that. You will find that it's not really critical. Arista made a change whereby they changed in their show version, software version, from software and small v to capital V. Was it really necessary? Did it change the game in any meaningful way to the user? Absolutely not. It screwed up a whole bunch of people. I know a bunch of tools that broke because of that change. Don't change it. You're absolutely right. I can't change the output. It's already out there. Yes, don't change it. That's my point. Treat that as your contract. If you offer, for example, if you're Palo Alto and the way you offer that is through a REST call, it is not a show command, but it is, they have actual API calls to do things. Don't change the output of those commands. At least then people know. Or if you're going to change them, put a schema on that, put a version on the schema. So when you change, people have a way to figure it out, as opposed to suddenly realizing, oops, under interface, now I have a new thing that I did not know existed, and that just broke my parser. And why is this important? Because every time you put out a new release, my ability to build this systemic view of the network is getting changed all the time. In the interest of time, I'll just continue for a few more seconds. Also, I don't like the data models that developers develop, because their perspective, again, is they think of in terms of data structures. But users are not thinking in terms of data structures. They want easily digestible specific information. Today, if I want to query, think of what I have to do if the information is flat like a table. It's very easy. I just do a grep or the equivalent of include or whatever it is that your platform provides. If it's a structured output, I have to use something like JSON query, which is harder to learn. And even when I do it, structure prevents easy correlation. If I simply say grep MTU, I have no idea what interface that MTU belongs to. If it's tabular, it's simple. If it's flat, it's simple. And I implement everything as flat tabular structures, and people are in love because they say this is so easy for me to find anything I want. It's trivial. And tabular output is automatically structured. It forces you to think of how much info and what to present by default, because you can't just cram everything into one place. But you also provide options for additional or alternative info as columns. Instead of trying to simply say, I'm going to cram everything into one large voluminous output, you simply say I have additional columns. Yes, it will overwrap the screen, but you have those values. People can take that. Screen wrap is a human problem, not a machine problem. Other things you can do, don't overload fields. Today, when I do show BGP summary, if the BGP is not established, the string will be under status. It will be not established or open or init or whatever else. If it is established, it's a prefix. How many prefixes have I exchanged? You didn't need to do that. As an example, Arista fixed that. Also give an option to display all the information. It's 2023. And again, I'll pick on Arista. Others have the same problem. They don't have a way to say show IP ARP VF. VRF IP, Arista has this option actually. Arista has show IP ARP VRF all. So that works, but they don't have it for multicast. iOS XE, even the latest release, does not support this. Show IP route has VRF all. Why doesn't show IP ARP have VRF all? Just make these kinds of things consistent. Forget the data models and everything else. And display possible errors in the output itself. Imagine you have to troubleshoot what's a simple differentiation between OSPF and BGP. When I do show BGP summary, I can see what the problem is largely. It's not fully there, but I can at least see that it's not established. With OSPF, the interface doesn't show up, or it says exchange, and I have to go look in the log to figure out what's going on. So in FRR, which is the free range routing thing, I implemented show BGP summary failed, which just tells you what the reason it failed is. Waiting for link local address, waiting for peer, no peer IP address reachability, whatever it is, because the protocol knows it's in your data structures. I implemented that, and that's pretty popular in FRR from what I understand. So it's things like these that you can do to help observability to network operators. It's not what you think is interesting. Because again, we have a developer mindset, not a user mindset. And be mindful also, Vishnu, of those who show up at IETF versus those who are actually in the trenches and don't have time to show up at the IETF. I've seen this over and over again. Reaching out to people who actually are doing the work and what's going on there is very different. So, I come to the end of my talk with this statement that Dizzy Gillespie, this famous jazz player, made, which is, it's taken me all my life to learn what not to play. Not what to play, what not to play. Just spend some time and say there are real problems to be solved potentially with networking. Maybe like the local optimization versus the global optimization, because of which we use RSVP TV and everybody hates RSVP TV. Or maybe there's the interplanetary networking to be thought about. Maybe it's something else. But there are real problems. Go look at them. Don't attempt to waste time with these data models. Be consistent with yourself. Make sure you don't change. But otherwise, Don't. Let us not do work that lands us on an XKCD cartoon, because that's what I see happening for a lot of these cases. We just do something that's new, that's interesting. We all feel good about that we invented something, but in the end, it just confuses the user and makes it really hard for them to make choices. And with that, I come to the end of my talk. I know that this is probably not what you have been made to think about or how you think about. And that's why I feel like this is an important perspective to keep in mind as you go about doing whatever it is that you do and what problems you choose to solve. Now I'll stop here.
Yeah, thanks, Dinesh. Very thought-provoking. I'm sure, we will not agree on a lot of things here, but there are a lot of things that we do agree on, that there are problems here with the way the things had done. And I think might be, I'm not 100% sure because you didn't touched on that part. When you say networks, what type of networks were you more focused on? Because that also would change your perspective a little bit, where network models help and where they have not been that helpful. And even at ITF, we have various operators coming in and trying to solve this problem. So saying that all operators feel the way Dinesh feels would also be incorrect. We have some on these calls as well.
Absolutely, but that is why you're right.
With, there is some ray of hope that we can still fix things here versus it's a big plan that don't
I would like to tell you, please stop that ray of hope. Therein them there lie danger.
Well, good that we have a second talk, which is all about ray of hope. So on that note, let's move and let's see.
I'm happy to come back and have this debate again, where it's a much more free form. I don't have any slides. I'm happy to go over. I think there are sections where it has worked, and but again, they say the exception proves the rule. And you're also absolutely right about the fact that coming from the perspective of what network, maybe in a specific segment that you operated on, it is better. Certain sections of layer 3 ISPs were better. I come largely from the enterprise campus data center side, where that's not been true. Yeah, and I've seen ISPs also have the same problem, but you're right. There have been sections where it has been a little more successful.
Yeah.
Hey, Dhruv, do we have time for one quick question?
Yeah, go ahead while I'm changing the slides.
So Dinesh, in terms of adoption, where are we? This is still a relatively new area, right? Operators still see value in SNMP, telemetry, and so on.
No, they don't. I think a lot of operators are beginning to move out of SNMP. I mean, if you were there between 2012 and now, there's a lot of hate, SNMP hate, again, which I think is misplaced. I don't believe SNMP is such a terrible thing. It's a little outdated, but it's not terrible. And but no, people want to move on. I mean, that's why, as Shraddha was talking about GNMI, a lot of people are looking at things like GNMI and they are getting enamored by streaming telemetry, which I think is not that interesting actually, because all the information is there. Just add the damn show command, which tells you, give me time between time X and time Y, and I don't need streaming telemetry. I get the information. For things like logs, again, for the things that SNMP trap did, I still think that those are important. Even notifications must happen. But otherwise, I think you can get by without that. And to the point of, what's the word for it, SNMP, people have been using it because they don't have a choice, not because they want to. Every place I go, that's what I hear. Am I having a sample bias because the people who talk to me are the ones who are unhappy? Sure, that's possible. That's why I am willing to hear other perspectives, but I'm fairly confident being in various conferences, talking to people of different natures who are not even my customers, so to speak, that people in general want to move away from SNMP if they can, to faster retrievals of time, because SNMP has a load associated with it, which apparently slows it down, etc., etc.
Okay, so let's move on. We are much ahead.
Thank you, everyone.
Of this.
Thank you.
So our next topic is understanding network digital map, which talks about more about the future of how we can add automation and improve automation in our networks. So we had a view from Dinesh. Now we can have maybe a competing view from Chin, who is developing a lot of solutions in this space and also quite active in ITF in network management space. So off to you, Chin. We are very happy to have you at RFCsWeLove for the first time. Chin has been active in the network management space for a long time. He works for Huawei. We have been colleagues for a long time at Huawei as well as ITF. Chin is also on the IAB Internet Architecture Board, and he has chaired various working groups which worked on the service model that Pawan was also talking about, L3SM and L2SM. He currently chairs an Alto working group, and he's been active in ITF in lots of areas. So it's really glad to have Chin at our RFCs We Love. So Chin, I'll stop sharing and maybe you can share your screen.
Sure. Thank you.
And again, a request, if you have question for Chin, please use the Q&A to raise your question. You can also raise hands if you would like to speak. Let's have another constructive and happy session. Chin, off to you.
Yeah, can you see my screen?
Yes.
The slides I already shared, so you can see that now.
Yeah,
right?
and if you can make it full screen, that would be really nice.
Okay, let me check.
Otherwise, it's fine as well. If you cannot, it's in Chinese, so I can't help.
Yeah. Okay, I cannot find the button
Okay,
to
no problem.
switch. So thanks for having me in this meeting. Yeah, first time to join this very interesting meeting. So sorry I missed the discussion for the previous speaker, but I see a lot of interesting point actually. So the talk I want to give is, understanding the network digital map. We know, network observability is a technology trend. Actually, I think you can see this network digital map can be the best practice of this network observability. So next. So as we know, we has already entered into the digital intelligence era. According to Gartner prediction, more than 70% of computing applications are most consumed by AI applications. So this AI or intelligence not only changes our personal life, but also enable thousand vertical, move toward network automation. However, as a digital foundation of network infrastructure, IP network, play more and more important role. And but the complexity of network connectivity is also increased exponentially. For example, cloudification and new services set a strict requirements for the network quality and service assurance move from connecting oriented to the user experience oriented. On the other hand, the number of the network maintenance engineers are not increased proportionally, which pose a greater challenge for network automation and operation. And also we see, autonomous networking, we call it autonomous driving networking, has already become the industry consensus. More and more operators take, autonomous networking as a strategy, set a layer 4 goal by 2025. Also thanks to, maturity of the network awareness technology, such as telemetry, like Yampushi gRPC and GMI, and also BMP, RP fix. This has already been published as RFC. So this really set a good foundation. And so many operators, they also claim they support level 3 of the autonomous networking. However, when we move from level 3 to level 4, I think still there's a lot of challenges faced by today's network operator to tackle. And I listed, 4 major technology challenges. The challenge number 1 is bad network observability. Especially in the multi-vendor interoperability environment, each vendor may choose a different telemetry tools, use a different measurement method. So the data to be connected is diverse, and the device type manufactured by each vendor is various. So the phenomenon of the data isolation or data isolation became very serious. So it's hard to extend network visibility to the endpoint, to the application, provide end-to-end network observability. The second challenge I see is high trial cost, and according to statistics, usually more than 70% of network downtime is caused by misconfiguration. However, you test and validate this configuration in physical real network environment, the trial cost is very expensive. If you want to introduce some new service, you also need to make sure the legacy service will not affected by the new service. So which make a try cost even higher. So challenge number 3 is reactive network optimization. Usually today's network operator deploy multiple dedicated line and with multiple linker and a large amount of the idle bandwidth. So it's hard to make a full use of multi-link resource or schedule on-demand resource. And in addition, usually we use the network controller responsible for network configuration. We use the network analytics platform to provide service assurance. However, the network controller is hard to provide. It's hard to have good coordination with network analytics platform, provide closed loop network management. Challenge number 4 is limited network openness. Usually OSS, BSS built as a silo, and without standard interface, it's hard to provide differentiated user experience that compare with e-commerce offered by the OTT. So to address this challenge, network digital map has been proposed. So this is, actually is our Huawei brand actually, and really focus on to address the challenge, especially for the network observability challenge. And so as we know, IP network operating is always challenging. You never have a tool that is good enough. Take a transportation map, a Google Map example. Can you imagine you can navigate the traffic without it? Is there any other alternative navigation tool you can leverage it? That's where network digital map grows. Compare with transportation map, Google Map, you have road, you have speed. In network digital map, you can see we also have traffic load. And so with hologram visualization and path navigation from the network to the application, so network digital map can provide 3 typical features. Feature number 1, network-wide resource visualization. So not only you have port visibility, link visibility, but also you can combine with geolocation or GIS coordinator, so you can quickly allocate a network element location accurately. Number 2, real-time network quality status visualization. So you can use big data and telemetry technology to process massive data in seconds. Also, you can you can use multi performance index such as latency, bandwidth, or energy consumption. You can represent the network quality in multiple dimension. And so with network scale, for example, 30,000 network node or 100,000 link, this kind of network scale. So in one word, you can use one map to manage the entire network. Number 3, the feature is precise navigation. So you can use path computation or path we call the cloud mapper intelligent algorithm, and to compute the path, so you can calculate the path to satisfy the various different service requirements. And in addition, you can detect service network service quality degradation in microseconds, so correlate network topology, so you can quickly locate root cause, trigger network optimization in a couple minutes. So to better understand what a network digital map can do, actually, let's make another analogy. So compare with self-driving car, auto-driving car, and also with autonomous networking. In self-driving car, we use transportation map to provide real-time traffic navigation. And in autonomous network, also we can use network digital map to build intelligent cockpit and to provide multi-layer, multi-dimension of network visibility, not only on the network topology, but also on network traffic and network service. In addition, actually, we can provide fully life cycle service management from construction to maintenance, from maintenance to optimization and operation. So network operator can really analyze, make a decision, take action on network topology, on network service, and network traffic. So what a network digital map, what a network function or network service that network digital map can provide. So let's give several examples. And first, actually, in these cases, you can see usually we target to 5G use cases. We have 5G customers. The challenges they are facing, the strategy they made is they want to improve network quality or network performance for the IP barrier network. And so many operators, especially in European, actually they participate in the P3 benchmarking test. Really, they want to identify the gap and want to take a leader in this benchmarking ranking competition. And however, the big challenge they are facing is large packet loss and long network latency. The time to be they spend for network topology reconstruction is not trivial. So to address the challenge, you can see network digital map can provide a 6-layer network visibility from physical layer, network layer to service layer, from slice layer, router layer to application layer. And in addition, you can see, on top of the service layer, we also can provide multi-dimension network visibility. For example, packet loss network digital map or network latency map. So with the network digital map in place, so we can provide the real-time SLA visualization, so we can quickly locate the root cause in a few seconds, and also we can help the network operator to greatly improve the P3 benchmarking ranking. So another example is so the question we want to ask is whether network digital map can provide security functionality. The answer is yes. Actually, take BGP router hijack or BGP leak as example. This is the challenge faced by both large enterprise and also network operator. And so to address the challenge, network digital map can be used. So we can use network digital map. They have some tools like BMP and BGPLS, and use these two tools. And not only we can connect network topology data, but also BGP router data combined with GIS geolocation. These kind of location data, we can provide BGP router visibility. In addition, actually, we can identify, perceive, and some suspected traffic, and also we can provide a real-time monitoring for these suspected traffickers, and then we can use path computation kind of algorithm we call the cloud map intelligent algorithm, and also we can use the network configuration verification mechanism to really help you identify BGP hijack. And for configuration verification, actually, this is a mechanism we can use for the online simulation. And the basic idea is you can take the original configuration and also the new configuration after network change as an input, so you can simulate not only network protocol but also network traffic, and also you can assess the risk from various different angles. For example, traffic path change or tunnel path change or BGP router burst, and so you can make sure the error will not enter into the network, so that you can provide high reliability for the IP network. And so the next, the question we want to ask, whether network digital map can provide intelligent operation and management. The answer is yes, and we actually can integrate like telemetry tools, OM tools, together with topology connection tools, so we can aggregate the OM data and so we can use, and then we can use the AI, this kind of technology, to do the topology reconstruction. Also, we can provide service impact analysis, so we can establish dependency relationship between the network incident and also network service. So in this way, we can really improve network maintenance efficiency and also can reduce the duplicate troubleshooting tickets number. And yeah,
can you share the screen again? I think there was a tiny disconnect in which the screen we lost.
From which page? This page?
Yeah, so you were talking about automatic troubleshooting.
Okay.
I think you can just move to the next slide. Just share the screen now because it got disconnected. We were able to hear you, but the screen went away.
Yeah, maybe, yeah. can you see the screen now? Troubleshooting page, maybe
No.
this one. Right,
No.
re-upload.
No, we can't see the screen.
You can't see screen. So maybe
it looks like you're not sharing.
Let me check. Maybe I reshare again. Let me check.
Yeah. Share again. Otherwise, I can share on your behalf.
Yeah.
So now we are seeing your desktop. Just open the
Yeah.
PDF.
Can you
Yeah,
see
you
now?
Yes,
it's good now. Yeah.
Go ahead.
Okay, great. So repeat actually what I said actually for
No need.
troubleshooting.
No
Okay,
need.
so I can continue. So in addition, actually, we also can integrate like a in-band flow measurement method, for example, in situ OM and also alternative marking divided by the IETF. So we can correlate flow statics data with network topology data, so we can quickly locate root cause in a couple minutes. So this kind of technology we can leverage it. So it is really helpful, to improve the troubleshooting efficiency. And the next, I want to share with you, the important feature, provided by network digital mapper, is, we use standard protocol. With standard protocol, we can, integrate various control plane technology and also verify protocol difference of each vendors. And also we can quickly adapt to each vendor's devices, so we can rule out the service very, very quickly. And actually, you can see this is nano digital mapper related standards. They cover not only data plane, protocol specification, control plane, and protocol specification, and also managed plane protocol specification. And also, I want to highlight for this managed plane. Actually, I see Pavan also mentioning actually IETFT's working group, and they do a lot of service level model. This really got a lot of traction from the network operator community, and so this really help to improve network observability and also provide a guarantee user experience. So many operator work together with the vendor to develop network service. Network as a service related standards. They use a young data model technology, so they cover not only network network topology observability, but also network inventory observability and path quality visibility, and also flow statics visibility. And you can see actually for network topology observability, IETF already published a lot of RFC related to this part. This is really not implemented in the network device, but implemented in the network controller, maybe OSS. So I think this really can help provide guarantee user experience and can really automate network management. And in addition, take a network inventory observability as an example. This is something we actually work together with many vendors like Cisco, Nokia, and also some operator like Vodafone and Telefonica and Orange. So we actually work together to propose these network inventory standards. Actually, this actually help to create a new working group called IV working group, which focus on network inventory management. I think a typical use case is, for example, in data center networking. I think maybe we can cover some enterprise use cases. In data center networking, you really need to plan the location or space of the physical box or physical component. So you can use this network inventory to help to better plan the location of the each physical box or physical component. In addition, actually, we have some other use cases. For example, in the network infrastructure, maybe integrate with both CT infrastructure and IT infrastructure. You really want to provide observability not only on the network device, but also endpoint device, server, and database. And so you can really assess each we call the asset, each asset risk. So these are some other use cases. So IETF really work on this kind of standardization worker. I think this is very useful to help a network operator to to automate the network management. And the next for network digital until now we already implement more than 70 control plane standards. The protocol cover span across topology connection and path computation, and also the policy population. And for past computation, actually, we work with many vendors in the PC working group to standardize, cloud mapper algorithm related standards. Actually, you can see the RFC we listed here, and not all of them, actually, just the part of some of them. And also, for network digit mapper, and the bigger vision is autonomous networking. So we see the network digit map as a level 4 technology for autonomous networking. So how do you prove this is a level 4 technology? So to answer this question, actually, we work European well-known third-party test center in tech, actually, to provide benchmarking test, actually, to test this network digit mapper capability. So the key scenario we test is the cloud networking convergence scenario, and also the capability we include in, such as network planning, construction, maintenance. And so based on that, actually, we work with Intech, actually publish Intech first autonomous networking level test and certification. And in addition, actually, in this year, actually, we also publish Intech first in digital map white paper. And we actually have a link. If you are interested, we can share the link to you, and you can see the details. I think that's all from my side. Actually, I gave a quick introduction for this network digit map.
Thanks, Chin, a lot. Chin, I think before we ask any more technical question, one thing which will be good for all the listeners would be, we had a first talk. And in that talk, I think Dinesh gave a point that the NetConf Yang itself, mainly because of the way there are different models for each vendor, it's a loss. According to him, the game is lost. And we might not be going in that direction, and we should more focus on network observability via existing tools, like making our show commands better, which was a totally different point of view from what you are presenting. So before we go ahead, I wanted you to also speak on it, based on this area for a long time. We know there are problems in NetConf and Yang, and some of which IETF has known for a long time. Are they solvable? Are they not solvable? What should be the takeaway for people who are listening to two different perspectives in today's talks?
Let me share some of my perspective. I think young data model, this kind of language is is a very important technology. Can be used to automate network management. Young got a lot of attraction, especially driven by the open config or maybe some other open RODOM, this kind of project. Each this kind of open source project, they use Yang. Actually, even in the open daylight, they use Yang. Actually, I think the model, the Yang data model language can be used not only can model the service, but also can be used to model the network protocol technology. I think we talk a lot about device level Yang. Actually, we see the competition between the open config Yang and IETF Yang, and IETF Yang actually because IETF process is very slow. Since we put more effort, I think this started from 2013 or maybe 14. Actually, IETF kick off Yang data model standardization, and we work with open config, but actually at the end, actually don't harmonize together. Seems really divided. But I think this part maybe a little bit failure, but still a little bit agree. For this stage, actually many vendor already they develop their own native Yang, proprietary Yang. Actually, they have a lot of operation experience, and they can can be used to to support this network automation scenario. And also I want to emphasize, actually for the service level model or network level model, you use on top of network controller or on top of OS IPSS. This can be used to define the service or some intent or service intent or realize service intent. And this is something I see not only network operator but also vendor. They get together to really want to have a uniform Yang data model. I think this got attraction, and if you follow MPO's Congress, actually, I think many vendors share some of the best practice. So at this stage, maybe I think for device level YANG, I think it doesn't matter you use native YANG, IETF YANG, or open config YANG. I think it's important we should get together to try to deploy the YANG data model, get an operation experience. Just in the last IETF meeting, actually they organized some side meeting, invite operator to share the operation experience. So they I think this is a very good starting point actually. And I think at this stage we already standardize so many YANG data model, and I think for service level YANG model or network YANG model, this is really led by Telefonica, Vodafone, or some other operator. They try to deploy this YANG model, get the operation experience. So that's very good. For device level YANG, still some people favor use open config. Some people maybe still using using native YANG data model. So IETF, I think their position, they in net model they work on the model versioning. So their position is it doesn't matter you use a native YANG or IETF YANG. But I think we can we can start from start from top down. You can really help develop some standard interface for the OS APS for the network controller, and then you move down to the device level. But I totally agree. Actually, some of operator, maybe even for developers, they get used to use command line. They are not willing to learn new knowledge about YANG data models. They are very afraid to get laid off, and so these kind of so I think we already have a lot of internal discussion with our product people, and also for some customer. I think really people should move forward. We should build more tools, just learn from the open config and see. But really, it's challenges. People already have the habit to use show command. They are not willing to shift to some other new tools. So network observability maybe is a new chance, but not used for the network conversion, but really focused on you may use some tools like telemetry or measurement method. I think still a little bit fragmented, because even for the measurement method, as I present, you have in Studio OM, maybe you have alternative marking, now have some kind of path tracing. So which tool the operator should use actually? So very confused. So really we need more guideline. But I think the previous speaker, I do think they share a lot of good experience. Maybe it's good input for the for some young data model developer guidelines, and so we actually work on these kind of standards. We make a base for these kind of guidelines, so maybe it's good input for that.
Thanks, Chen. I think Thomas, you please go ahead and speak. And very happy that you are here joining us.
Yes, sir. Hello, everybody. First of all, I think this is a great conversation we're having here, and especially it's amazing how you bring these two opposing views together. And I thought I like to join the conversation because I'm bringing here a network operator's view on the table, and I have with Swisscom probably around 5, 6, 7 years experience in network telemetry, and I'm recently also talking with many other network operators, so I start to understand not only the network operators' needs and challenges we have, but also how we need to better interact with the ITF. And I fully agree on both presenters that it's important to understand the user's needs. And maybe here to comment, I can say that we need definitely like an abstraction layer which helps us to understand how everything is connected. And what we did in Swisscom is like similar what now Queen Vu was presenting with the network digital map, like from a connectivity service perspective. Swisscom itself developed already something very similar to have actually this kind of view over the top on the network, and then collecting network telemetry data and make this available to the users. And what changed over the last 5 years is that users are actually moving away from CLI, from show commands, and they're going towards database SQL queries. So I think at the end, it's all about making the data, first of all, to the user accessible, so it can be easily queried. And when he does the changes in the network, because usually one change on one side of the network is affecting another part of the network. So we need to have, there is a need of having an end-to-end view on the network, and we need to provide from all the different network planes this visibility and give them a consolidated access to it. The second challenge is I see is basically in standardization. I mean, ITF is great in standardizing network protocols, and vendors are great in adopting those network protocols. And therefore, from a visibility perspective, we see that BMP BGP monitoring protocol is currently have a sweet spot here, because BGP is everywhere the same. There are no interoperability issue, and BMP is natively basically sending us the data from the network. So there is no transformation on the network device happening, and therefore we get a unified view on the network through BGP. However, BGP doesn't solve us the configurational aspect. So therefore, like what Queen Ruhi is presenting, it's important that we are working on the digital map on the ITF network.young, that we are working on those imports and augmentation, making sure that all the configuration items towards this layer 3 VPN or layer 2 VPN service, that we can make those dependency also from the configuration side visible.
Thanks, Thomas. They're very good inputs. Chin, do you have anything to add? Otherwise, we'll move ahead. We have taken enough time for everyone.
Yeah, I think I have no addition to add. I think Thomas, definitely right. Actually, we already work together. I really think we this kind of technology channel is network observability. We need more focus on how different YARN model put together, how they can correlate and mapping. Actually, this is something we really want to focus on, and so we propose this kind of IV work. I think some of IV work can address some of these part, but not all of them. And so I see, yeah, we expect more work maybe done in some kind of new working group in the ops area. They will focus on network deployment and experience connection. So maybe some so that's could be the good platform to further to get more input from the operator to see how this challenge can be addressed.
Yeah, thanks, Chin. And actually, it's a good thing that's part of my slides as well, which I will now just take a very few minutes. Some of you may not have attended the ITF 118, so my job has also been to just bring in some quick news so that you can be updated on what's the latest thing that is happening in the ITF. One big news that is coming your way is we have a new ITF area. It's going to be WIT, which is going to stand for Web and Internet Transport. The idea here is that some of the web-related working groups in the ART, which is application and real-time, will move to this new area. Most of the transport working groups will move to the WIT area. And basically, the old TSP and transport area is going to close down. And there is some juggle between some security-related ART topics, which are moving to SEC. And similarly, some ops and int-related TSP topics are also moving out. So this is going to be a new area. So if you open your ITF data tracker, this might be a new change that you will see just before the next ITF. So that's an update for you. BOFs are pre-working group sessions. This is the time where ITF decides whether this is the problem that they want to work on. Is there enough interest in the community? Is the problem clear? Is it solvable? All those questions are usually handled in the BOF session. So this time we had 3 different BOFs related to security and identity. So that continues to bring a lot of new work in ITF. The first one is DULT, which stands for Detecting Unwanted Location Tracker. So this time was the second time they met. This was their second BOF. This time it is a working group forming BOF. That is what the reason for BOF was, to decide whether we are ready to form a working group. Is the charter clear? Is there enough interest in the community? Things like that. And this problem is very much specific to detecting unwanted location tracker, the air tags from Apple and other things that we have seen, when they can be exploited to track someone, and ability for us to detect that a tag is moving. In fact, these things you might have seen already in Apple and other places, that warning coming to your devices. The idea here is so that we can standardize them, and it can be used across the industry in a standard way. The second one, SPICE, which stands for Secure Patterns for Internet Credentials. This is an identity-related first BOF, very much related to digital wallet, the things that EU and other places are trying to standardize. Again, the aim is, can we do this in a standard way that can be applied both by the governments as well as private organization to as a digital identity that you can carry in an interoperable way. The second one is WISME, which stands for Workload Identity in multi-system environment. Here, instead of an human identity, we are talking about the identity of a workload, and especially in an environment where you have multiple systems. So when the workload moves across clouds, for instance, how we can apply identity in those mechanisms. So these were very interesting BOFs. We hope that we will have working groups coming out of these sessions. The next set that I want to introduce is some of the recent working groups that have been formed. We had CATS, which we in fact discussed in the last RFCs We Love, where we have Adrian talking about it at the time when the BOF discussions were happening. Good thing that it is now chartered, and most of you might be aware of this already. We had a Chin talk about Ivy, which is the network inventory YANG. We have satellite related use cases coming in time variant routing. That is when we have a planned link down because of rotation of the satellite or other use cases. How can we add schedule as a part of our routing decision from the start? So this is again an interesting working group called time variant routing. In security, we had Keytrans. In transport, we had CCWG. Those who are developing on Linux, for instance, have know about BPF and eBPF. There's a working group working on this to standardize this within IETF. This might be interesting for some folks, that why IETF is doing this is because earlier this was only for Linux, but now the use case can be applied for Microsoft and other environments as well, in IoT, for instance. So the aim is to do this in a standards body in a standard way rather than tightly coupled to a particular implementation like Linux. And we also had structured email SML as one of the new working groups. Just a very quick intro of the recent working groups. This was the working group that Chin was also talking about, NMOP. This is currently in charter discussion. Network observability, network management are very important topics at IETF, and that's why we wanted to cover them today in the RFCs We Love as well. The hope at IETF is that we could have an operator-led working group that deals with operator problems and not just deal with like the details of protocol and modeling and how this YANG model needs to be done, but look at a bigger scope and think about network management operations at a higher level. And operators can come and discuss issues. Some topics of interest are how we merge YANG telemetry with Kafka. How do we map different of these models that we talked about today, OpenConfig, IETF, vendor, the network digital maps, anomaly detection, path validation, incident management. All of this would be some of the proposed topic. And hopefully we would have this working group charter before the next IETF. Some topics of interest, especially from operations point of view, since that is our topic of interest today. E-Impact is a IAB program dealing with sustainability and environment impacts on internet technology, looking at metrics, for instance, that how would we measure our energy consumption in a standard way? What would be our metric? How would we make them useful? Things like that. IPv6 operations, we had an interesting presentation on Happy Eyeballs, which has been used extensively. There is a plan for a version 3 that has been proposed, which was pretty good, and it got discussed in various working groups. We had an operational presentation from our neck of woods. The NITK Surathkal has been working on moving their campus network to IPv6. So we had some students present how they are going about it. This is a student-led project which has been we had help from IISOC and INTC working with NITK with funding from APNIC and ISIF Asia in this project. So we had all of us coming together, and it was very good to see students lead this work and present it at ITF, which was very well received at the V6 Ops as well. We had one more interesting presentation from Jen about how in the Google Enterprise Network, they have tried to move to IPv6 mostly. We know that enterprise networks are the, are the bottleneck when we see in IPv6 deployment, and how at least Google has been able to move their enterprise network to IPv6 mostly. And this was a very interesting talk from Jen. And some of the others that I've listed is Grow, where the BMP works gets done. We have TSVWG, NetMod, again, focusing on Yang model versioning. This was a problem that Dinesh also talked about, like, oh, how do you keep changing the models? So ITF is well aware of it. And there is the whole concept of how do we do Yang model versioning and able to deploy new versions of Yang in our networks in a clean way without creating more problems. Some of the other topics are 6-man, Spring, which I know many of you care about. At 6-man, extension headers can remain to be a hot topic. We have various documents dealing with that. Compression in SRv6, that's finally making some good progress. Also, the security issues in SRv6 network, that's being discussed. There's a proposal related to SRv6 to assign a new ether type, which gets discussed in int area, and even things like how do we use IP in deep space, that were pretty interesting talks. Side meetings are also pretty interesting these days at ITF. These are not part of the ITF official agenda, but this can lead to work getting chartered in ITF. This could be pre-BOF discussions. And so there have been some good side meetings that the community here would be interested in. AIDC deals with how, large scale AI and model learning impacts our network, how these large scale DCs are dealing with that, and what are the new technologies, especially in ITF space, that might come out of it. Again, these are very high level discussion as of now, but we need to filter them into clear problems that ITF can solve. Again, how we apply AI and ML into networking domain. That was interesting side meeting. Yang Kafka integration, some of which Thomas talked about, and led by Thomas as well, which was very interesting. Network digital map, again, something that we discussed today. Another thing which has been discussed a lot is how do we do network monitoring in an encrypted network? And SAT CDN is one of that work coming out of it, where how content endpoints can give signals to the network in an encrypted way. Again, making sure that the privacy is maintained fully, not to break the encryption, but even in an encrypted network, how we can still cooperate between the content endpoints and the network endpoints, when we hope some good work come out of it, because this is, from a network management point of view, this is a real problem that we need to solve. Some other ones were IP in deep space, metaverse. What are the requirements from metaverse that can actually come to ITF, especially with respect to latency and the requirements to handle metaverse. 6G also can lead to some requirements in ITF. So these are at high level side meetings that were being discussed, and most of them are maintained in a wiki. You can find some link to GitHub, for instance, related to that. And final, this is my last slide. We would be having an ITF 119 in Brisbane in March. For those who can travel, the registration is open. So start registering, talk to your managers, and hope some of you can travel to 119. And those who cannot travel, ITF works in a hybrid fashion. Remote participation is pretty good. It's in fact one of the best when it comes to other SDOs we have seen. And also, for those who cannot afford to pay the remote fee, the remote fee waivers are easily available. So please attend. It will be at least closer to the time zones that we are in. So I hope to see more of you participate at ITF 119, either in person or remote. And with that, we come to an end to RFCs We Love. If anybody has any last questions on what happened at ITF, any doubts that we can answer, please feel free to jump ahead.
Dhruv, that was a very good summary. Thank you.
Oh, thank you. I don't see any questions. So I'll give you your rest of your weekend back and hope you enjoyed. Feel free to reach out to us if you have any thoughts on future events. We are planning connections for sure. So if you have thoughts on that, please reach out. Thank you.
Thank you, folks.
Thanks a lot.
Thank you.
Thank you. Bye-bye.